AI agent versus LLM workflow versus RPA versus agentic AI. Understanding the key differences. Introduction: the AI confusion problem. In today's rapidly evolving AI landscape, there's significant confusion about what constitutes a true AI agent versus other automated solutions. Many organizations mistakenly label advanced LLM workflows as AI agents, missing crucial distinctions that impact their technology choices and business outcomes. The reality is that not everything connected to a large language model can be termed as an agent. Depending on your use case, you need to choose the right Gen AI solution. So how do you identify the right solution for your specific needs? Let's break down the four major approaches by examining their workflows, capabilities, and ideal use cases. LLM workflow, the foundation of text generation. How LLM workflows operate. LLM workflows represent the most basic form of AI interaction. The process is straightforward and linear. Step 1. User input processing. A user provides a prompt or query. The system tokenizes this input, breaking it down into digestible pieces for the model. Step 2. Model architecture engagement. The tokenized input is processed through the model's neural network architecture. The system applies pre-trained knowledge from massive datasets or general domain data. Step 3. Text prediction and generation. The LLM predicts the next best text sequence based on patterns learned during training. A contextual text prediction happens, generating a single comprehensive response. The user receives a one-shot response with no follow-up actions. Key characteristics of LLM workflows. Purely text generation based. Focus is entirely on producing written content. No multi-step reasoning. Cannot break down complex problems into smaller parts. No external tool integration. Cannot access APIs, databases, or other systems. Stateless operation. No memory of previous interactions or context retention. Real-world use case. Meeting transcript summarization. An LLM workflow excels at taking a lengthy meeting transcript and generating a concise summary highlighting key points, decisions made, and action items discussed. 2. RPA, Robotic Process Automation, Rules-Based Efficiency. How RPA systems function. RPA represents the traditional automation approach, following predetermined pathways with precision. Step 1. Trigger recognition. The system receives a trigger, either manually initiated or scheduled. Common triggers include form submissions, file uploads, or time-based events. Step 2. Workflow identification. The system identifies the appropriate workflow based on predefined rules. Decision trees guide the process down specific automation paths. Step 3. Script execution. Pre-written automation scripts are loaded and executed. The system follows exact sequences without deviation. Step 4. Application interaction. RPA bots interact with applications through user interface automation. Actions can include data entry, file manipulation, or system navigation. Step 5. Process completion. The workflow completes with standard or alternative path execution. Output is generated or status updates are provided. Key characteristics of RPA. Fully rules-based. No learning or adaptation capabilities. Predefined workflows only. Cannot handle scenarios outside programmed parameters. No autonomy. Follows exact instructions without decision-making. Deterministic outcomes. Same input always produces the same result. Real-world use case. Automated email responses. When a customer submits a support form, RPA can automatically send a pre-formatted acknowledgement email, create a ticket in the system, and route it to the appropriate department based on predefined categories. AI agents, autonomous task execution. How AI agents operate. AI agents represent a significant leap forward, combining intelligence with autonomous decision-making. Step 1. Input phase analysis. The agent receives an input or task request. Unlike LLMs, the agent analyzes what tools and approaches will be needed. Step 2. Dynamic tool selection. The agent dynamically selects appropriate tools and APIs, can choose from both internal tools and external integrations, makes intelligent decisions about which resources to utilize. Step 3. Multi-step action execution. Performs complex multi-step actions to accomplish the goal, can adapt the approach based on intermediate results, executes tasks in logical sequences. Step 4. Data collection and processing. Collects data through API calls to external services, queries databases for relevant information, processes and analyzes collected data. Step 5. Memory management. Maintains both short-term memory for immediate context, stores long-term memory for future reference, uses memory to inform decision-making. Step 6. Result compilation and output. Compiles results from multiple sources and actions, generates comprehensive outputs based on task completion, provides detailed responses with supporting evidence. Key characteristics of AI agents. Task-oriented, focused on accomplishing specific objectives rather than just generating text. Tool-using capabilities, can integrate with external systems and services. Autonomous decision-making, makes independent choices about approaches and methods. State and memory maintenance, remembers context and learns from interactions. Real-world use case. Intelligent error triage. An AI agent scans error logs, identifies potential causes using external knowledge bases, correlates with recent deployments, determines severity levels, and automatically creates detailed JIRA tickets with reproduction steps and recommended solutions. 4. Agentic AI. Orchestrated multi-agent systems. How agentic AI systems function. Agentic AI represents the most sophisticated approach, utilizing multiple specialized agents working in coordination. Step 1. Orchestrator coordination. A central orchestrator receives the input and analyzes the complexity, determines which specialized agents are needed for the task, divides the work among multiple agents for parallel execution. Step 2. Specialized agent assignment. Planner agents coordinate overall strategy, review agents validate approaches and results, research agents gather specific information. Each agent has specialized capabilities and focus areas. Step 3. Parallel data retrieval. Multiple agents simultaneously retrieve data through API calls. Database queries are executed in parallel. Information gathering is distributed and efficient. Step 4. Inter-agent communication. Agents communicate findings and coordinate next steps. Information is shared across the agent network. Collaborative decision-making occurs. Step 5. Result processing and refinement. Agents work together to refine and improve results. Multiple perspectives are applied to problem solving. Quality assurance through peer review among agents. Step 6. Context synchronization. All agents maintain synchronized context. State information is shared across the system. Memory is updated collectively. Step 7. Coordinated output. Results are compiled from multiple agent contributions. Final output reflects collaborative intelligence. Comprehensive solutions are delivered. Key characteristics of agentic AI. Multi-agent collaboration. Multiple specialized agents work together. Autonomous task distribution. Intelligent allocation of work across agents. Coordinated autonomy. Independent operation within collaborative framework. Scalable intelligence. Can add more agents for increased capability. Real-world use case. Intelligent warehouse management. A robotics warehouse system where a planning agent optimizes picking routes, robotic control agents manage physical item retrieval, inventory agents track stock levels, and coordination agents manage packing, labeling, and shipping logistics, all working together seamlessly. Comparative analysis. Choosing the right solution. Decision framework. Choose LLM workflows when you need simple text generation or content creation. The task requires single-shot responses. No external system integration is needed. Budget and complexity constraints favor simple solutions. Choose RPA when processes are highly standardized and repetitive. Rules-based logic is sufficient. Integration with legacy systems is required. Compliance and auditability are critical. Choose AI agents when tasks require multi-step reasoning and decision-making. External tool integration is necessary. Context and memory are important. Autonomous operation is desired. Choose agentic AI when complex problems require multiple specialized capabilities. Parallel processing would improve efficiency. Collaborative intelligence provides better outcomes. Scalability and flexibility are paramount. Performance comparison matrix. Capability. LLM workflow. RPA. AI agents. Agentic AI. Autonomy. Low. None. High. Very high. Flexibility. Medium. Low. High. Very high. Tool integration. None. Limited. Extensive. Unlimited. Memory context. None. Limited. Yes. Advanced. Multi-step reasoning. No. Predefined. Yes. Advanced. Learning capability.
static, none, limited, continuous. Scalability, linear, manual, good, excellent. Complexity handling, low, medium, high, very high. Implementation considerations, technical requirements. LLM workflows require model access, tokenization capabilities, and basic API integration. RPA need workflow design tools, application connectors, and monitoring systems. AI agents require LLM access, tool integration frameworks, memory systems, and orchestration capabilities. Agentic AI need multi-agent frameworks, communication protocols, distributed computing resources, and advanced orchestration systems. Cost implications. LLM workflows lowest cost, pay per token model. RPA medium cost, licensing and maintenance. AI agents higher cost, complex infrastructure requirements. Agentic AI highest